Good morning, everybody. So we are going to go over our last video for atom in the periodic table. I'm going to go kind of quickly through it because it's something you should have covered during 5th grade. But if you don't understand it, please, please, please ask for a Falcon Time Pass or come see me after school during homework club. So the first part of our video is about organic versus inorganic compounds. So first we have to go over what exactly is a compound. So really, it's when you take two or more elements and you chemically combine them. So it's not just mixing them together. Something has to occur where they are like attached to one another. So if you look down here at the examples, you'll notice that the elements hydrogen and oxygen are written kind of squished together. That's the way that I always know it's a compound, is if it's written all squished together. An organic compound is going to have carbon. So for example, C6H12O6, that's actually the chemical formula for sugar, glucose, and it comes from a living thing. So in the Bill Nye video, he talked about cow poo being organic. It's because it has carbon in it. Another one that you should see with the carbon is hydrogen. So you should see carbon and hydrogen together in order for it to be organic. If it doesn't have carbon in the formula, then it's inorganic. Pretty simple. So if you look here, a lot of people get confused right here. See how it says CL on your SOL? It will be in the Tahoma font. So if it is a capital I, it will have the top and the shoes. So this is definitely an L, and it does not come from a living thing. So water is not organic, and salt is not organic. So the meaning for organic is really different than kind of what you may have previously thought of organic being. So like you go to the grocery store, you get something that's organic, you're basically getting something that isn't using pesticides. So it's not the same definition, so don't get the two confused. Okay, so now we're going to go over elements, compounds, and mixtures. So you guys should have a pretty good hold on what a mixture is from our first 2 units. You guys know about elements because they're on the periodic table. You can't break them down any further. So the smallest part of an element is an atom of that element. That's the only way it keeps its identity, because as we learned, atoms have a certain number of protons. If you change that number, you are changing the element, and that is not okay. You are changing the identity. So pure substances, you're going to see these 2 words together quite frequently. It just basically means that it's an element or a compound. It's made up of one thing. So for example, compounds can also be pure substances, like water. Every atom of water is water. So when you drink water, you're just drinking water, not anything else. Compounds, as we discussed while going over organic and inorganic, are elements that are chemically combined. So that would be like if I took hydrogen and oxygen and I put some electricity in there and they combined and now they're stuck together. You can't take them apart unless you do another chemical reaction. And it will always be in the same ratio. And what the word ratio means is if you look at water, there will always be 2 hydrogens for every 1 oxygen. For salt, there will always be 1 sodium for every 1 chlorine. And for carbon dioxide, there will always be 1 carbon for every 2 oxygens. It has what's called these are the chemical formulas, and you can only separate them by chemical means. You can't physically separate them. So mixtures is when you take an element or a compound and you physically mix them together. It doesn't even need to be an element or a compound. It could be another mixture that you're mixing with another mixture. So we talked about solutions, and solutions are mixtures. They're what we call homogeneous mixtures, meaning you can't tell the difference. And then you also have heterogeneous mixtures, which we also talked about, would be like beach sand, where you can see the shells, you can see the seaweed, all that kind of stuff. So we're going to skip that one. You guys are going to do a Paperclip Web in class on Monday, and it will help you practice what an element, a compound, and a mixture are. So compounds are going to be paper clips that are attached to one another. Elements are going to be singular paper clips, because each paperclip is an atom. And then a mixture is going to be when you have either an element and or a compound next to each other in the same, I guess, square. So you have two different things in the same square, but they're not connected. That would be a mixture. So let's practice. You can pause it after I ask the question so that you can take some time to think about it. Just remember, an element is going to contain just one type of atom. A compound is going to contain two or more different atoms joined together. And a mixture contains two or more different substances that are physically joined together, not chemically. Okay, so rocks. These rocks, do they look like they're made of different things? They would be a mixture. Copper. Copper is found on the periodic table, therefore it is an element. If you look on your periodic table, it's towards the mid-right. It's in the transition metals and it says Cu. These jelly beans, they're a mixture. They're all different. You can tell the difference between all the parts. Table sugar. Remember we covered that when we went over this? C6H12O6. So it's a compound. You can also have table sugar that's C12H22O11. But as you can see, the elements are written all smushed together. So it's a compound. But it is a pure substance. So all the stuff in this container is all made up of the same thing, the same types of atoms. Diamond. It's made of carbon. It's an element because carbon's on the periodic table. Tea. You take water and you put a tea bag in there. So it's a mixture. Salt. NaCl for the kind that you eat. So it's a compound. They're written all smushed together. You have multiple elements written all smushed together, meaning they were chemically combined. Neon gas is an element. It's found on the periodic table. Salad. It's a mixture. You can tell the difference between these parts. Pure water. So first of all, it says pure, which means it has to be a pure substance. So we are not looking at mixture. We're looking at either element or compound. Is water found on the periodic table? No, it's not. So water is a compound, H2O. It's made up of more than one element that has been chemically combined. Aluminum is found on the periodic table, therefore it's an element. Lemonade, water and you mix sugar and lemon juice together, so it's a mixture. Silver is found on the periodic table as Ag, therefore it's an element. Sand, we've talked about this one. It's a mixture. Now, if you have pure sand, it's actually a compound because that's what they make glass from. But sand that's just like sitting on the beach is going to be a mixture. So here's a nice little flow chart to help you go through. So you have matter. Matter can either be a pure substance or a mixture. So basically, can you tell the difference? Have you physically combined it? Then it would be a mixture. Okay, that's it for today. Hope you enjoy your Thanksgiving break.